3.6 zeros of polynomials. So there's this thing called the rational zero theorem or the rational root theorem. The idea is you can factor any polynomial using this theorem. So what they do is, first, we call these P and Q, 1 and 4. The idea is if you find the factors of P and Q, so let's say factors of P. So for example, 1 times 1 is 1, but of course you have your negative version, negative 1 times negative 1 works. Here are your factors of P, and then here's your factors of Q. So Q is 4, so 1 times 4 is 4, and 2 times 2 is 4. So these are your factors of Q, of 4. So then when you take P divided by Q, so if I was to match this one to this one, so that's 1 over 1, which is 1. This one and this one. 1 over 2 is 1/2. And then match this one and this one. Positive 1/4. So the idea is one of these factors, one of these P over Q is going to be a root of this. So it looks like this. Using one of these, you got to do a quadratic formula. So 4, 0, -3, -1. Let's say I use the -1 version. I have 4 here, -4, -4, +4, +1, -1, -2. So I did not get a 0 here. That means that the -1 version did not work. So then I got to try out the other one. 4, 0. So just try it again. Do it again. Try the +1 version. So I get 4, 4, 4, 4, 1, 1, 0. I got a 0, so this one does work. So if you have, so this is 4x squared plus 4x plus 1 and x minus 1. So this is a +1, this is, so therefore that's a -1. So this factors from here. So to find your zeros, I can factor this again using ACB, using guess and check. So this factors to be 2x plus 1, 2x plus 1, and then I have a x minus 1 here. So your roots, or your zeros, are x equals -1/2, x equals +1. Okay, so because to find zeros or to find your roots, you need to have everything factored before you can do it. So I got another one. Or we'll skip that one. You can do that one by yourself. 28. So again, my P, here's my Q. My factors of P are +-1, +-2, +-3, +-6. These are all the numbers that multiply to get 6. My factors of Q are +-1, +-2. So then my P, Q, if I was to match them, first I have this one and this one. So that is 1 and 1/2. Then I have to match this one and this one. So that is 2 over 1, which is 2. And 2 over 2 is 1. So we don't need to rewrite. You can if you want, but if you have 2 over 2, that's the same thing as this one. So there's no point in rewriting it. And then go down the line. I'm going to match my 3. +-3, +-3 over 2, and then 6, +-6, +-, and then you don't need to do 6 over 2 because 6 over 2 is 3. So These are your possible roots. So there is a lot. And how do you know, is there a fast way to figure this out? There is a fast way. If you use a calculator, so the idea is if I plug in a number into here, I need to get a 0. Because a root, if this is my graph, a root is when it hits there. Therefore, there's an x value, and then the y value is 0. So if I plug in a number into my function, I should get a 0. So just go to your calculator. So I'm going to do 2 parentheses to the third power plus x squared minus 7 minus 6. And I'm going to plug in my possible values. So let's say I start at 1. I got to answer a negative 10. Therefore, positive 1 is not a root. Try the negative 1. Negative 1 gave me a 0, so negative 1 is a root. So I get negative 1, and then 2, 1, negative 7, negative 6, 2, negative 2, negative 1, positive 1, negative 6, positive 6, 0. So this is 2x squared minus x minus 6. And then I have my x plus 1. So that's my factor form. So you already know this root is x equals negative 1. This one, you had to use the quadratic formula because this is not, you cannot ACB this. So use the quadratic formula. It goes negative 1 plus minus negative 1 squared minus 4 times 2 times negative 6 all over 2 times 2. So I have a 1 plus minus. So this is a 1, positive 1, plus 48. So this is 49 over 4. We know that this is 7. This is equal to 7. So this is 1 plus minus 7 over 4. So I have it's either 8 over 4, which is equal to 2, or 6 over 4, which is equal to 3 halves. There's your roots. Maybe it did factor nicely. It did factor nicely. That's okay. Because you will have to use the quadratic formula when you cannot factor. And then sometimes you will get imaginary numbers. Like 42, you're guaranteed to get an imaginary number here. So your P, your Q. So I'm going to just skip to the PQ part. Plus minus 1, plus minus 5, plus minus 17, plus minus 85. So check. If you put this in your calculator, you're going to see the negative 5 is going to work. So 1, negative 5, 8, negative 40, 17, negative 85, 0. So one root is x equals negative 5. The other root, using quadratic formula, you get negative 8 plus minus 64 minus 4 times 1 times 17. 4 times 17, 8 to 68. And then this is going to be negative 4, which we know that that's negative 2i. So we have negative 8 plus minus, not negative 2i, just 2i. Plus minus 2i over 2. Reduce this down to negative 4 plus minus I. So that's 2 roots, 3 roots. So that's how you do it using the P and Q system.